in the physical world, we naturally recognize and remember and interact with people, places, and things with almost no effort, right? It's so effortless. Nobody in the physical world thinks about that. What's the identity system I'm using? How am I logging in? You don't have any of those thoughts, right? It's just part of your natural life to walk around recognizing, remembering, and interacting with people, places, and things. Online, that isn't true, as we all know. So imagine, for example, this restaurant experience on your phone, right? You have to have a special app to find the restaurant. Once you find the restaurant, you get in there and you realize that they use this other system for figuring out how to seat you. So you have to download that app, and you don't have an account, so now you got to log into it. And then they take you to your table, but you don't see your friend at all. But the hostess insists your friend is right there in front of you, but you don't see him. And you remember, oh, I'm Android and they're iOS. Okay, good. I would download this other app that I can use to actually see my friend who's in front of me. And now we can't actually talk to each other without downloading the restaurant's app to have conversations within their space. And so we have to download their app before we can even, I mean, it's just ridiculous, right? But that is the digital world that we live in. Every interaction we have is administered by someone else. If there's some administrative authority that is intermediating every interaction that we have online. What I would like to see is a digital world that is as natural as the physical world, where we effortlessly, that's hard to say, effortlessly, right? Effortlessly, see, I can do it fast. Recognize, remember, and interact with people, places, and things. That the identity system just fades into the background. That nobody ever thinks about identity systems except like people in this room who are actually building them. Everybody else, it's just, they never even think about identity online. They don't have to think about passwords or usernames or which app they're using or any of that. It's all just gone. Now, why do we have the problem we've got? We all know the internet. This was the internet in 1974. You'll notice University of Utah in there. The internet was built without an identity layer, right? You say that, everybody knows it. Famous New Yorker cartoon that kind of made that idea famous, right? On the internet, nobody knows you're a dog, which we adopted as the motto or the theme for the logo for Internet Identity Workshop. In 2005, Kim Cameron, who is Microsoft's chief identity architect, and was until this month, right? He just retired, talked about the laws of identity, as he called them. But in that paper, Laws of Identity, you can go get the PDF, just Google Laws of Identity and get the PDF. There's lots of different references to it. PDF is his actual paper. He talks about an identity metasystem, right? And Kim says, different identity systems must exist in a metasystem. It implies we need a simple encapsulating protocol. We also need a way to surface information through a unified user experience that allows individuals and organizations to select appropriate identity providers and features as they go about their daily activities. The universal identity metasystem must not be another monolith. It must be polycentric and polymorphic, which by polycentric, Kim meant more or less what we mean when we say decentralized. And polymorphic, he meant that it needed to be flexible. It needed to function for any kind of identity interaction that needed to take place. So this idea of a metasystem is a system that you use to build other systems. The most obvious example we have of that, at least for people in this room, is the internet itself. The internet isn't a communication system, although we frequently talk about it like this. It's a system for building communication systems. It's an underlying protocol that you can build a interaction system with. So we have email, we have web, we have lots of protocols that sit on top of this substrate that we think of as the internet. People build communication systems on top of the internet. The internet creates a common user experience. It creates, right, right now the user experience is kind of faded into the background because everything is always connected. But, Wi-Fi and things like that, that's a common user experience. I don't have to get a different kind of network connection to do email than I have to get to do the web. I have a common experience when I want to do those things. So that's what Kim said we needed in order to solve the identity problem that we have online today. We need a meta system. My thesis, my proposal to you is that Sovrin is that meta system. So why do we build identity systems? Most fundamental answer is we build identity systems because we want to be able to trust something or someone. We want to trust that the person at the other end of the connection is the same person who created the account. Right? That's why we authenticate people. More generally, as I said in my earlier discussion about the restaurant, we want to be able to recognize, remember, and interact with people, places, and things. Identity has kind of gotten to the point where the only thing we really think about is authentication, but really it's about remembering, recognizing, and interacting. That's what identity allows us to do. And as I kind of emphasized in the restaurant example, the only way we do that online today is inside someone else's administrative system. So Amazon creates an administrative system for their purposes, which is fine, right? They need that, and it's great. I'm not saying it's bad that they have this, but we're inside their administrative system. I'm inside Google's administrative system. I'm inside, whatever other interactions I have, and I don't have any independent way to remember, recognize, or interact with people, places, and things, except through somebody else's administrative system. And we all know that the problem is there are lots of these. So think about what happens in the physical world. Physical world, you go into the pharmacy and you want to fill a prescription, and they say, we need to know that you're over 18 in order to fill this prescription. What do? US, we call it a driver's license, right? Because a driver's license has a birth date on it, and people trust the driver's license division to do a good job of identity proofing. And they conveniently package it up into a nice little card that's easy to carry around and is relatively tamper evident. Right? Not perfectly so, but relative enough for the purposes that we're talking about. This is a way that we transfer trust, right? We're transferring trust from the division of driver's license, the driver's license division in DPS, to CVS. CVS says, oh, I can trust that your birthday is really this day because DPS said that it's really this day. This kind of interaction where we use what somebody else says about us in a different context is common. Now, driver's license is a specific credential, right? And it's easy to get lost in this idea of what I call monument credentials, driver's license, birth certificate, passport, those kinds of things. But in fact, we do this kind of thing all the time. Like these guys mentioned, for example, that they're part of Dr. Stevens' lab, and I know Dr. Stevens, and I know what he's doing. So now I know something about him. Right? They've transferred information to me. Doesn't mean I trust them. I'm not going to give them my car keys, but I know more about them than I did 5 minutes ago. There's all kinds of credentials that we use, right? The so-called monument credentials, like your passport and your driver's license and an employee badge, right? But there's also others like membership cards and school transcripts and airline tickets and even receipts. You may not think of the receipt that you get when you go to Home Depot as a credential, but it is. And it is a way of transferring trusted information, right? You get this piece of paper and you take it with you. Now when you come back to Home Depot, you can prove to them that you really did buy that piece of plywood on April 26th and you used a particular credit card, they know all of that because you have this piece of information. So you're transferring trustworthy information to them. So you can think of this as multi-source identity, right? The idea that your identity is not just based on a set of credentials, but also on a collection of relationships. And through these relationships and the information that they're willing to say about you, you collectively create an identity. Now, it turns out this identity isn't an artifact, right? It's not a JSON file you can send to someone. This identity exists only inside your head. It's the collection of all of these relationships and all of these credentials. That's really the identity. So there's no identity in the sense of, oh, I'm going to show you my identity or whatever. I can just show you information. I can create a relationship with you. That's what we mean when we talk about digital identity, right? Is this kind of ephemeral thing that's inside your head. So Sovrin is based on this idea of verifiable credentials as its fundamental way of doing information transfer that is trustworthy. So you can imagine that I, for example, could have a relationship with my employer, and my employer could give me an employment badge, right, or an employee credential, says that I'm an employee. Now I go to the bank, I want to take out a loan, and they say you need to prove that you're over that you make over $70,000 a year, and that you've been employed for 3 years in order to get this loan. I can use my employee credential from BYU to prove to the bank those two facts, and they can give me a loan. So now transferred information from BYU over to the bank. And this can happen without any kind of connection, without the bank having to talk to BYU in order to know that. This is the way we have done things for hundreds of years in the physical world. And it's almost impossible to do online. If you needed to prove to somebody that you're over 18 online, about the best you could do is take a picture of your driver's license and send them the picture. There's not very many other ways to do it. So there's a whole set of things that we do all the time in the physical world we can't do online. And that's the idea behind Sovrin and what Sovrin's trying to do.
That's what I had to do to sign up with the new Apple Card.
You had to send them a picture of your driver's license.
Both sides, yes.
Yeah. Which we all know that JPEGs are completely secure. You can't tamper with them, right?
Well, I did send it from my Apple phone, so maybe
they might have something specific. Yeah. Yeah. So when the bank gets this proof of that I make over $70,000 and I've been employed for 3 years, they want to know a number of things. They want to know 4 things that we can prove cryptographically. They want to know first that who issued this credential, right? It was issued by a particular institution. They want to know that it hasn't been, that it was issued to me. They want to know that it hasn't been tampered with. And they want to know that it hasn't been revoked. These are things that we can do cryptographically. We can do all of this in a way that gives people reasonable trust that who was issued by, it was issued to me, that I haven't tampered with it, and it hasn't been revoked. So that's one set of things that the bank wants to know. But the bank also wants to know, who is BYU? And do I believe BYU when they say that Phil makes over $70,000 and has been employed for 3 years? That is not a cryptographic question. That is a question of what I'll say call human trust, right? That's based on institutions and other things that we have done in the physical world for a long time. So we can add a whole nother set of information to this trust triangle, and think about the idea that the bank wants to be able to trust BYU, wants to know who they are. Now, it turns out they're a local bank, they probably know who BYU is. So once they get the identifier and know that the identifier belongs to BYU, they're happy. But if it were remote, they may not have any idea who BYU is. So even having the identifier and knowing that it belongs to a particular institution called Brigham Young University may not be enough for them to actually trust BYU. So then they might do other things, right? They might require a business registration, or they might want to see BYU's accrediting information or something else, right? In order to create more trust in this relationship. So I'm trying to think about where I want to go next, because I could go on for a long, long time. So few things that are important about this credential exchange. First, it's decentralized and it's contextual, meaning that nobody is telling BYU what kind of employee credentials to issue. BYU is deciding that completely on their own, and they're doing it for their own purposes within their own context. Right? There's no central authority saying BYU has to do it this way. Second, the issuer, BYU, is free to determine who they want to give credentials to, who they want to revoke them from, right? It's completely within their power to make all those decisions. I, as the holder of that credential, I'm free to choose whether I show it to someone or not, or even pick between different credentials. So the bank may accept different credentials for different purposes, and I may have choices. I can make those choices. I choose what credentials I want to hold. And finally, the bank, the verifier in this case, is making their own decisions about who they trust and who they don't trust. So there's no central authority that's making all of this happen. And so you can imagine, you squint just a little bit, if everybody were using this credential system for all kinds of things, not just passports and driver's licenses or employee cards, but even things like receipts and membership cards and any kind of information you want to trust, that you could get to the point where you really do have a large collection of information that you could use to prove things to people. If you squint just a little bit more, you could imagine that that could happen more or less automatically based on rules that you've set up. And now it starts to feel a lot more like this natural world we're trying to get to. I don't think it's there yet, but it's you could imagine how you could get there, right? That now there is a way for information about people, places, and things to be recognized, remembered, and used in interactions. I'm going to skip past this and skip past that. We really should be doing like a demo at some point, but anyway, I want to just talk briefly about these ideas. So there are 4 things that make Sovrin work, 4 technologies anyway. First is something called a decentralized identifier. The centralized identifier, think of it like a URL, but it's not a uniform resource location. It is just an identifier. And they're decentralized because there's no central party that's saying how they're created or who creates them. Anybody can do it. They can be exchanged pairwise, right? So that's how you create relationships, is you exchange these decentralized identifiers, or DIDs, to create a pairwise encrypted channel that can be used to communicate. Verifiable credentials, we've already talked about these, and how they work. What I haven't mentioned at all is the idea of zero knowledge proofs, which are built into this whole system of credentials, so that you can just share the information that's necessary and do it in a way that is trustworthy and you can prove that it hasn't been revoked. A system of peer-to-peer agents. So if we're going to exchange DIDs, we're going to create a relationship, you need some software working on your behalf and I need some software working on my behalf, so that we can do that exchange, set up that connection, and do whatever other interactions we want to do. So those agents combined with credentials and DIDs are what provide us with this ability to recognize, remember, and interact with lots of different people, places, and things. It's based on this collection of peer-to-peer agents. And then finally, there is a distributed ledger. Remember I said when the verifier, the bank in my example, wants to know these 4 things that can be verified cryptographically, right? That who issued it, that hasn't been tampered with, that it was issued to me, and that it hasn't been revoked. And I also said that we want to be able to do that without the bank talking to the employer. The way you do that is you break that chain with the ledger. Right? So the ledger contains a credential definition that holds a schema, holds a DID for the issuer, and holds a revocation registry. And when you get the credential from me, actually you get the proof of the credential, you get the credential definition. You can look it up on the address. You can check the revocation registry. You can see who issued it. You can look at the schema. You can get a signature. You can use the signature to verify that the credential hasn't been tampered with. The ledger is what provides all of that beautiful magic underneath so that the bank doesn't have to talk to BYU to know that this credential is correct. So this all happens in a stack. And this gets to Kim's important point about monoliths, that there's a stack here. So we talked about the ledger. Ledger provides this foundational element of a root of trust. But on top of that is this system of peer-to-peer agents that interact with each other and talk to the ledger occasionally, right? There's not a lot stored in the ledger, but what is stored there is important. Those two things together are what I think of as providing this layer of cryptographic trust. This idea that all of the things there, the guarantees that we're after there, can be done with cryptography. On top of that, you have the credential exchange, and that happens, and as we've talked about, everybody's making their own decisions. And whether we believe those decisions or not depends on what the governance is for who is issuing credentials and why they're issuing credentials. That layer is a layer that we can think of as human trust. So if I give you a transcript from BYU, do you trust it? Well, there's a lot of decisions. That's a human decision. That's an institutional thing. Now the labels on the left-hand side are going to shift, right? Right now they say cryptographic trust and human trust. But we can think of that bottom layer as being the identity metasystem. And we think of the top layer as being a context-specific identity system. So if the top layer is an employee card, that's one identity system. If it's a university transcript, that's a different identity system. If it's a driver's license, that's a different identity system. All designed and all governed for a specific purpose within specific contexts. So this is how we get lots of identity systems built on top of a metasystem. Right? The metasystem's providing the protocol for credential exchange, providing the means of interaction and the agents, is providing the cryptography that allows us to trust all of that. And on top of that, we build different identity systems based on credentials that have a consistent user experience, have an encapsulating protocol. Those are all, that's how this all comes together. So in that paper, Kim said, as users, we need to see our various identities as part of an integrated world, which nonetheless respects our need for independent context. If we build administrative identity systems as one-offs, and everybody solves their own problem, you don't get this. You get it when it's based on this underlying layer, this underlying identity metasystem. Let's get past that. So, closing out, because that's probably overtime, right, Lynn?
You're good.
An identity metasystem is the way we start to approach an identity layer for the internet that provides a consistent user experience and allows us to have more natural lifelike experiences in our digital interactions. My belief is that as computers come to intermediate more and more of our world, this kind of natural interaction is going to become more and more important. We can't get to the world we want to build without having an identity system which supports those kind of natural interactions. But I think there's a more important idea. And a more important idea is that if we build a digital world where every interaction we have is within someone else's administrative system, we don't build a world that has the same properties of autonomy and agency that the physical world gives us. I think that the Internet of Things, the identity systems that could come to pass with the Internet of Things pose a real challenge to human autonomy and agency. That by building an identity metasystem that has those principles baked in, that creates agency and autonomy for users, we're not just making something that's more flexible and easy to use. We're making something that actually has the ability to protect people and give them real digital lives just like they have real physical lives. So that's what I've got.
Thanks, Phil.
So that's my contact information. I blog at windley.com. I'm PJW at BYU.edu. I'm also PJW at Sovrin.org if you want to contact me that way. And I tweet at Windley. So is there time for questions? Or should we let Adam come up?
No, time for questions.
Questions is why we're here.
Yes, questions.
Questions, comments, yeah.
Ideally, who maintains the ledger? Is there a single ledger, or are there multiple ledgers, or who maintains that public blockchain?
So in the case of Sovrin, right now, there is a ledger. And that ledger is a public permission ledger, meaning that the validator nodes are known. You know who they are. Public, meaning that anybody can read, and in the near future, anybody will be able to write to the ledger. There is, theoretically, no specific reason why there needs to be a single ledger. In fact, a lot of the interoperability work that's happening in the Hyperledger Ares project around agents means that I could take a credential, as long as the agent protocol allows us to exchange credentials interoperably. I probably don't care technically, and that's an important distinction. Technically, I don't care if the DID that issued that credential is rooted in the Sovrin ledger or rooted in the ION side tree for Bitcoin, or rooted in Varus1 or some other ledger. So technically, I probably don't care, because I'm going to have a DID. I can use the DID to find out what ledger it's on. I can look it up on the ledger. And remember, I stressed interoperability. I can get the credential definition schema, etc. Right now, that's not all a given, but it is very possible from a technical standpoint. Now, I might care, non-technically, where that identity is rooted. Sovrin, for example, has a governance framework which very clearly delineates how the ledger is run and lots of other aspects of what's going on. So the verifier may say, I trust more an identity rooted in Sovrin than I trust one rooted on the Joe's blockchain that he stood up last night in his basement. So those are more in the human realm of what they trust and why they're going to trust them. But technically, from an interoperability standpoint, you could imagine multiple ledgers, and indeed, I think that's probably where things go. Other question, Sam?
Yeah.
You already know all the answers. What are you asking questions?
Well, I want your thoughts on this. One of the things that I think can happen with the meta system, where you start with the individual, is you can start to build group identity and get group trust, and maybe even have group ledgers. I wanted context, that is an important part of identity is our
Yeah.
with groups, and we gain a lot of trust via via the interactions within the group.
Can you repeat the question, please?
Yeah, so the question is, how do we do group identities? I'm simplifying a lot, but what do I think of that? My thoughts are, I think group identities are vitally important and something which we haven't really talked about a lot. And we're going to need to, right? Because clearly, I mean, if I go to dinner with a group of 4 friends, you could imagine us somehow participating over, you know, n squared over 2 point-to-point connections between those 4 people. But, you know, in this room, right, the math gets unwieldy. So it would be nice if we had some way of doing group identity, and yeah, but I don't think we're there yet. But Nathan, you?
There's 2 things I think that are important to mention here. One is this is why the Aries project is really important, because we want this protocol compatibility across lots of different blockchains. But it's not really for the reason that everyone should have their own identity blockchain. It's for the reason that you just pointed out, where anything you're doing for wallet synchronization and for just managing multiple hardware devices that you might have under control turn into a consensus process. Dropbox's syncing algorithm is in some ways a rudimentary form of consensus. And when we have this idea that we can agree collectively between more than one cryptographic key, we effectively get a private permission blockchain, right? Which means that all these group identities can form really on the fly. As long as I can believe some credential about your criteria for being a member of my private chain, we can come to consensus about the pieces of state we need to track collectively. So the idea is that from the agents themselves, that's really where this concept of the ledger emerges. What this gets to that's interesting at a technical level, I can't speak necessarily for how things are going to go politically, is that it ends up being a natural monopoly on a root of trust at the top. Because everyone needs to have that ability to know that the thing I'm relying on for your cryptographic commitment is immutable. You can't take it away from me. I can rely on it when I go to exchange credentials other places. And that really ends up with kind of a scary scenario, which is one of the reasons why I believe that the foundation has a really important role to play in the ecosystem, is that we want to make sure that that root of trust follows principles that get us to the place where we do have independence, where we do have our own agency to act independently of other entities. And when we change our mind about how we want things structured, we have the ability to do so.
So when you talk about private permissioned ledgers, is it possible that those could be implemented through multi-sig anonymous credentials rather than actual blockchain-based ledgers?
Well, and in fact, bootstrapping the system, we start with blockchain to get root of trust, and then we start building out this agent ecosystem. Once you get key management on the edge, you have to stop thinking about it that way.
Yes.
It starts with the keys at the edge, and it builds the other
Key
way.
management is the key. You start from the key management. And to have trust in key management requires some trust basis out on the edge. And the ledger is not necessarily the right place for that, because that centralizes your key management. If you can have other trust bases, you can have, you know, multi-sig keys. And one of the things that's really critical is that the controller of the key can define the ordering of events. The one thing a global ledger gives you is global ordering of events. But that's only needed if anybody can create events out of order. But if you are the only source of an event because it's your identity and your keys, you get to define the order of events. You don't need a global ledger. You just need something that is immutable, that when you communicate it, other people can trust.
Right. Well,
this
is where we get into
basis.
this is where we get into the recursion case, right? Because you have to have the base case to build recursion, but at the same time, you need to have confidence you're getting to an end goal. When I start with something that I can recurse up to, I know I can get from A to B. I mean, you're in a completely different context than I'm in. I need confidence that I have a way of pivoting from my context to your context, no matter what that context is. So both of these arguments have to happen simultaneously. You can't do one or the other. You have to do both.
Other questions? Yes.
I remain concerned about the interface between the human trust and graphic trust, which is to say, let's assume that all the technical cryptographic sovereign pieces are in place. Now what we know is that Agent 1 can trust Agent 2, and that Agent 1 can create assertions that Agent 2 can verify. When I walk into Wells Fargo and say, I want my loan, how do they know that I am the person who controls Agent 1? That I am the owner of Agent 1?
Yeah, so this gets to, this is getting above the cryptographic thing, right? So,
Right.
so if I want to know, do you control the key, that's pretty easy and I can do that cryptographically. But there are a lot of scenarios where what I want from you is I want more than just, you know, you are an agent somewhere online. I want to know this person standing in front of me controls this agent. So I could ask you for other things. I could ask you, for example, not to reveal your credit card and your driver's license, but I could ask you to prove to me that you have a valid credit card and a driver's license that has the same name on it as the employee credential that you're giving me. Right? So now what I've done is I've upped the stakes for someone who wants to commit credential fraud, because they have to have a lot more information in order to make that proof. And remember, I said you don't have to reveal those documents to me. You just have to be able to prove to me that you have them and you control them.
First of all, there's no way I can possess a key because it's just too hard to remember. I can only possess a device that is stored there.
Or a piece of paper that has them.
Or a piece of paper that has it
Have you tried Sequest?
But even possessing a piece of paper is equivalent to possessing a device. It's the possession of something. It does not prevent identity theft by someone stealing the credentials. If I am going to pretend to be you and I get a hold of your agent, I can now pretend to be you.
So Nathan has a comment, but before he makes a comment, I would say that this is probably a discussion that's too big for answering right now, but we have an entire white paper called What If I Lose My Phone? That deals with these scenarios and how you can be protected. Now,
what if I lose my phone and don't know that I lost it?
So this is the pod people problem, right? So if someone comes and replaces you with something that's an identical copy of you, how would anyone outside of you, anyone except for you, be affected?
Yeah.
It can turn into a difficult philosophical argument. In some ways, you've made the problem actually much simpler by trying to make it about cryptographic keys, and it's actually more complicated than that. And the keys to solving it are you need to rely on the continuity of the identifiers, not the continuity of the cryptographic keys, and that actually turns into a complicated problem. That is why the pivot point between different identity contexts is actually so important, because it's one of the only tools you have to enforce that quality about something or someone is that you can prove things that are not relevant to just one interaction, but you can across multiple interactions. It means that it's really easy to make the argument that if everybody uses a common identity meta system, the problem gets better. But you have to be able to prove it so that you get there here, right? I need to be able to show that you can get cryptographic keys and that you can own and control them with enough confidence that everyone else will start to believe that those keys are yours, right? Because if you're going to lose those keys every 3 or 4 months, you're constantly repeating the thing that happens on GPG keys all the time, where most of the keys out on the GPG clouds are basically abandoned. Then you don't build up any continuity or confidence that allows you to then apply these restrictions.
yeah, so the level of indirection supplied by decentralized identifiers is an important part of this story. And I would recommend you read the paper, but please keep engaging with us on this because we actually are starting a whole kind of effort to work through the issues of credential fraud. We think we have good answers. We want to make sure that we're dealing with credential fraud in a realistic way. So Nathan is a big player in this, but Daniel Hardman, who's on the TGB, is also very interested in this. You're going to see a lot more in the near future about that. And I would just say also that, if you lose your phone and you don't realize it, that is a problem from a security standpoint. But the more pressing problem, the more urgent problem is really, how are you going to update Instagram? That's the real.
What is this?
Social media site.
Yeah, nobody who's concerned about security does.
Might actually practice.
No, I was just saying I'm interested in the problem.
Dan?
As a risk of making a shameless plug, there's actually a BYU student, Ken Stevens, now who's working with us on this problem. That is building mnemonics that are cryptographic strength. So the assumption that you can't remember a private key, we're challenging that. We're building mnemonic aids that will allow the average person, without being an expert mnemonicist, to be able to remember a private key in your brain, which means that now your brain becomes your device. And if your brain gets separated from your body, yeah, that's a problem.
Okay, I am going to quit. I'm going to quit because I do not want to take any more of Adam's time.
No, I have questions.
You're just stalling.
No, I'm not stalling. I'm not well, I made almost the exact same PowerPoints. So you took all my material. No, I'm joking. Okay, so if you go back a few slides to the verifier interacting with a credential from BYU and the added trust framework. So this governance authority creating a governance framework outlining what credentials can be used in what way, and then a validator accepting, oh, I accept this governance framework. I feel like that could be used to address group identities. So like I could have a Reddit or some logging group that creates a governance framework outlining what type of credentials for login or different things. So as a developer, I'm very interested in what that would look like in code. What's the data structure? Where can I get more information about this?
So that's an interesting question because I've never really thought about it existing in code, but I think it is important that we ask ourselves how we can support these kinds of things through code. So that these kinds of things at the bottom, this bottom triangle, there are hundreds, thousands, hundreds of thousands maybe of these in the world already, right? They already exist because people create them all the time. The example I use all the time is college transcripts. If I show you a transcript, why do you believe it? Well, you believe it because you can associate with an institution. Well, why do you believe that institution has any authority to create a transcript? Well, there's an accrediting body, right? The Northwest Association of Colleges and Universities is the accrediting body that accredits BYU. And so that is a trust framework, right? It's an organization, and there are lots of schools that are part of it. And so that whole group starts to create this trust framework within which we believe transcripts, right? But there are, like I said, there are hundreds of thousands of these things everywhere. Some of them are very low level, some of them are very well developed. I don't know what kind of code can be used to help those things, but I do think it's an interesting tie-in to the group, because these are definitely groups, right? They're groups with a specific purpose.
Do you have any, besides white papers, like losing your phone, like do you have any sources you would point me to for any of us? You want to learn more about governance framework?
Well, the Sovrin governance framework is a good source for the governance of the meta system itself. The governance working group does have some think they have a task force, right, that's talking about how these things develop. And if you're interested in that area, that's probably a good set of calls to get on, is that task force that's working on trust. Do you have more details already?
Domain-specific governance framework task force. And so it's a task force subset of the entire governance framework working group that just focuses on domain-specific governance frameworks. And they're developing ones right now for CB Ledger and for animal identity and for I think one more other use case that will have its own governance framework.
If you're a technologist or developer who's working on this, the best place to get started and get involved is actually the UD semantics group, because we're working at expanding out what guarantees in terms of types, annotations, other inferences that you want to add to your credentials, so that when the verifier gets them, they know what you meant as an issuer. And out of that part of the system is where we're going to end up with governance framework objects on the ledger. Because what happens is we start making commitments to common pieces of meaning. And from those, we decide, oh, we're all talking about the same thing. Let's start adding further annotations about the rules of how we're issuing and what sorts of conditions we want to put on verification for these types of objects. And that's where we get into use cases of, we all know we mean the same thing. And from there, to use cases of, how do I discover something to mean the thing that I want for this particular resource to be released, right? And that gets to the use cases of search and discovery that we haven't been talking about a lot yet because of correlation risk. But as we get these pieces of non-correlation platform built out, we will be starting to talk about it towards the end of next year.
So what I thought in your question is you might be asking things like what cryptographic support is there for building these sorts of systems, like root keys. So that you actually have.
My question could be broad as that.
So,
Yeah.
So for example, I don't know, anybody here remember the Pentium 5 disaster? Yes, right. So they put a unique identifier in every Pentium chip, which would allow them to trace the chip and all the operations on the chip. They thought this is a great way for us to, Intel thought this is a great way for us to manage all of our chips out there. And all the privacy advocates said, oh no, now you can track all my behavior because there's a unique identifier on my chip. And so they had to take that out of the Pentium chip. Well, the result was actually a multi-year effort within Intel to figure out how can we have a cryptographic root of trust via some sort of identifier that doesn't destroy the privacy of the individual chip. And the result of that was a group key system that is now an open standard called EPIC. Which allows any chip in the Intel family that supports it to be able to sign things, and you know that it's a member of the group, you just don't know which chip in the group, so you have her privacy across all the chips.
And in fact, there's
problem.
Yes, I know.
And in fact, as we're working on right now, MFN credentials, the new anonymous credentials protocol we're building out we're working with BBS plus signatures and functional standard signatures that will allow us to do threshold signing for credentials for these exact same reasons. And that opens up a lot of interesting possibilities. But in order to really accomplish a governance framework object that's not controlled by any one central authority or party, those types of threshold issue credentials are going to be important. We want things like blockchain consensus to be able to be reflected in interoperable credentials.
Okay, thank you, everybody.
Thank you. What are we looking at as time-wise?
Well, I'm expecting to look through that door and see lunch on the table there when lunch is here. So we have at least lunch.
We have a few minutes.
So what I told Adam that he could take 15 to 20 minutes on kind of an overview of what how to get involved and how to get started with using Sovrin products or using our networks, that kind of thing. I'm not sure which of those directions he's going to go, but Adam, you're up.
Yeah, so I wanted to build off of what Windley went over, because he pretty much covered everything I wanted to talk about. So I was wondering if we could have like a question and answer type of session where I ask you guys questions. Like no?
No.
Okay. So I was talking with Lynn earlier in the week trying to figure out what's my monologue for our meeting, what would you like me to cover? Lynn came up with the topics and asked speakers. And I was like, I'm going to start out, we need to tear down the silos of data right now. But I realized what Lynn, when you ask Lynn, what's the introduction to Sovrin? He has a very different approach of introducing Sovrin. He goes, well, on the ledger side, this is our data structure, this is our permissioning, this is how we set up our permissioning, this is what you have to do to use our ledger. I was like, well, yeah, but we're not covering, well, why we need a ledger, this, right? And so I asked a few other people, where do you start? Where do you introduce someone into Sovrin? And every person I asked gave a different starting point that actually was the most familiar with them. And so I was thinking, well, if you're hard knock, right, and you ask old developers, what language should I learn to program in? They're like, well, C or assembly or Cobalt, right? And then I was thinking, well, if you're going to learn Sovrin, there's this getting started document. There's a sample getting started, and it took me the better part of months to crawl through this thing before I felt like I could actually walk among the Sovrin community and understand our working group. So I point you at this getting started Python script. It's really heavy on all the topics. But in reality, I think a more generalized approach is much more appealing. I don't know why scaling is off. Someone in our community came to me over Rocket Chat and said, hey, in a month, I'm going to build one of your guys' agents is going to issue credentials for my organization. We're going to have validation logins, right? And I kind of was like, oh, yeah, 1 month. Okay, great. How can I help? What questions do you have? I can answer, right? And so in a month, he was able to produce this demo. Let's see if I can turn up the sound. Oh, I don't know if he has sound. Well, this is showing Ozma on the right, which is an open source agent in our community, establishing what we call a connection. It's a pairwise DID connection. A DID is a decentralized identifier that has a public-private key associated with it. After he establishes a secure connection with the organization over the line, he's able to request, oh, here we go. The connection gets established, getting ahead of the video. I watched this before, I remember. The organization on the left then creates a credential to offer it to the Ozma app on the right. I can speed this up.
You got it over here. Receive the credential.
Yes, so he's received the credential. I believe he accepts it, and then he uses this credential to log in. So there's a lot of these demos out right now showing zero knowledge credentials, verifiable credentials being used to log into facilities, right? Like a key management, password management system. And it's the most simple thing you could do with our credentials. But some of our demos, I guess I built up to not a good finale with that. But this shows the interaction of an issuer issuing a credential and then issuing a credential presentation request, and a holder then presenting the credential and fulfilling a request and allowing a verifier to verify that that credential was issued to that individual by a certain entity without the verifier having to go interact with the organization that issued it. This is important because it removes discrimination power from organizations to say, my credential can only be used in this way, right? So it provides you the same real world promises, credentials like driver's license provide you, right? So I could start selling lemonade and provide a discount if you present me your driver's license, student, something, I want to track your information one way or another. And a holder can use their driver's license, student ID, however they want, while the verifier, me, I don't have to actually go and interact with whoever issued, right? So we provide that same functionality in our online interactions. I will post links to all of these videos. I also have another one. I think he actually taught.
By simplifying the customer journey of a KYC process. The demo begins with Sukalpo casually browsing the iBanking site of Acme Bank. While browsing, he suddenly stumbles upon the ad of the loan. Sukalpo was thinking to make a Euro trip for quite some time, and some extra cash will surely help. So he clicks on the ad, and the site wants him to log in or register. Since he is an existing customer, he clicks on the sign in button and logs in. Once he logs in, he sees that to apply for the loan, Sukalpo needs to prove that he is a resident of Singapore. At this point, Sukalpo feels a little demoralized, as he knows document submission for KYC is an arduous process. He needs to get an address proof from someplace that the bank states, and then go to the branch to submit the document, and then he needs to wait for the proof to verify and the loan to be processed. So he thought of closing the page and continue doing his work. As he was about to close,
I haven't watched this in a while. All right. I would have summarized. Would you like to summarize, Lynn?
The bank has also given him a link to get this proof.
So he landed on a website that requests a certain proof of some sort, and he's discouraged because he realizes it's quite a hard proof to present. Basically, the same scenario as I presented before. This is a little off track. What was the question I was answering with this one? Lunch isn't here yet. Okay. So, any questions on Zucalpo's? Yeah.
Well, this is a question. So you were saying companies cannot restrict how a user uses the credentials that they issue to them. Is that right? Is there any way, like, I can imagine a situation where a company wants to restrict that, say like it's a, some sort of spy, and they, want to restrict maybe who they can reveal that sensitive credential to. Is there any way that that would be possible?
Nope. All the power is placed in the holder of the credential. And so when someone requests, hey, to interact with me, to buy my lemonade at my lemonade stand, I want to know your secret spy information, right? All the power to restrict me from seeing the special attributes of your spy credential is in your hands. So you must take care not to expose that to me as a lemonade stand owner, right? But as it is now, that the power is all in the holder. Yes. Sam.
There's been lots of credentialing systems that have been developed that solve that. They're usually interactive, right? So the goal of Sovrin is to have a non-interactive credential that the holder holds. You don't have to keep going back to the issuer. But you could always have an issuer-based dynamic credentialing scheme where you would give permission to somebody to go to the issuer then issue a credential just to that, just to the particular person, with different consent and different confidentiality concerns. That's a more complicated infrastructure. That's not a new thing.
So it would be like having a database, and then I issue a credential that allows access to certain parts of the database.
Yeah, well, it's like a registry.
Yeah.
The registry does similar things. The government registry, you go to the government anytime you want to get a permit or something like that, they would issue the permit has the revocation date, something like that. So it now becomes an additional complication.
Yes, and it goes back to when you use Google as a identity provider, right? I'm going to log in with my Google account. I click, oh yes, this fun app's going to track my gameplay just with my Google account, right? and you read under, oh, I'm allowing this random game I got off the App Store to access my contact information, this information, right? And you realize, oh, everywhere I allow Google to prove my identity to third parties, the third parties are able to actually get information about me from Google, and Google knows what dumb apps I'm downloading off the App Store, and can tailor or sell that information to someone else, right? So inverting that whole thing where you're more private, it's more difficult to track and profile, right?
But I would add that given the holder control of the credential disclosure, if you want certain guarantees of the end user, that's a different problem. It doesn't matter whether it's the holder or the issuer. The problem is, how do you ensure that they comply with whatever disclosure, it's like a GDPR kind of a thing, right? You're going to give them some information, you make them sign a contract that has consent, you have a way to enforce it. I mean, once you disclose information, it's like only other things constrain the behavior. It's not like your verifiable credential is like the destructive tape in Mission Impossible that once you view it, it disappears.
That would be pretty cool. Okay, sorry, you had a question?
You have an open source wallet there.
Yes, this you can download this and build it.
Okay, where?
I'm glad you asked. That is a good question. If you go, it currently is in Matter Global repo. So if you go to GitHub and look for Matter Global Ozma, you'll find this wallet. I believe they're working on
Desktop or only a phone?
It is based on Xamarin and has the UI for desktop app, Android, and iOS.
And it's written in?
It's built on top of Aries Framework. Is that the new name of it? Aries Framework .net. So C#.
C#.
And using the Xamarin framework. And so this is a really slick just UI that accesses
I don't care
that
about
code
the
on floor. Right, yeah.
UIs are irrelevant. We only care about the back.
Right, okay, so the backend, yes, this is very important. So this is an example of using the Aries Framework.net repo, which is also open. So you could take this as an example of using that framework underneath, which has the protocols and the consumption of libIndy to interact with our ledger and create credentials. And you could go and produce your own app fairly easily. Right. Probably difficult, but still, it's the nature of the beast, right? We're on a frontier. So your question was, where was the repo? Did that answer? So one of the places you can get started is actually going to the repo I just suggested, ariesframework.net. That is a C# framework of the protocols, the current protocols being used in Aries. That's also placed in the Hyperledger Linux Foundation repos. Aries' goal is to become cross-compatible with all the ledgers in Hyperledger.
How is Aries related to Sovrin? You keep saying Aries. I'm not sure everyone knows what that means.
Yes, background, context. Michael would like this because he wasn't here when we did last week context. So the Sovrin Foundation source code is placed or stored, served from Hyperledger Linux Foundation. The Linux Foundation has a Hyperledger project. Linux Foundation saw that there was a lot of these blockchain companies coming about, and they wanted open source blockchain technology. And so they said, hey, we'll create Hyperledger, and we will host this code bases for public consumption. And we were able to land our code. Sam, you're grinning like I'm confused. Please correct me.
No, I'm not. I'm thinking about it.
Oh, okay, sorry. And sorry to pick on you, Sam. We're friends, right? And lunch. And so the Hyperledger in Indy is where Sovrin's main code base lives. In Hyperledger Indy, you'll find Indy Node, Indy Plenum, and that is the server-side blockchain code software. And then you'll find libindy. Libindy is the SDK that's used to interact with our ledger. On top of that, there's also an Indy CLI that's used mainly for maintenance of the ledger, not issuing credentials yet. There's plans to add features, but it's mainly for if you have a node or if you want to do admin type of actions on ledger, you go to Indy CLI. So we recognized a need. We wanted to be interoperable with other ledgers. So Hyperledger, the Linux Foundation, has other projects like Fabric, Sawtooth, and they have ledgers that are targeted at solving different problems, almost similar to Indy. I forgot another part of context. You should have caught me. Hyperledger Indy. Indy being short for identity something something. Independent identity. Yeah. So we're focused on solving a blockchain-based identity, right? And there's projects that are focused at other things in Hyperledger, and we want to be compatible with all those other projects. And we'd also like them to critique our ideas of verifiable credentials, right? We'd like to actually have more minds in the mixing pot, right? And so Aries was born to fulfill this need. Aries is where code that will interop with all the ledgers belong. Right now, almost all the code in Aries is based on top of Indy and libindy. And so the question was, why do I keep bringing up Aries? What the heck is Aries? Aries is our agents. So Ozma, when it lands in, or if it lands in Hyperledger Linux Foundation, it would most likely belong in the Aries project. That answer your question?
Yeah.
What was I rambling on before? The .NET framework is a great place to go. They have a getting started. The only hiccup you run into with their getting started script or example script, desktop example, is you have to have ngrok installed in your path. Otherwise, it works great out of the box. I've actually used it on the Raspberry Pi, so it's pretty slick. One of the other places you can go if you're just wanting to get started is Aries Cloud Agent Python. An organization in our community, BC Gov, they are trying to bootstrap their government system, their credential system to use our credentials. And in so doing, they've produced software and artifacts that are very useful. And Aries Cloud Agent Python is one of those useful tools. And they generously donated it to Hyperledger Foundation. And so this is a great place to start. They have a getting started demo with documentation. What's nice with theirs is they have a play with Bon, which is a Docker in the cloud. So you can jump on here, and they have copy-paste scripts that you can copy-paste right in here that will spin up one of their Aries Cloud Agent Python. Well, this is embarrassing. I don't know what's happening here. Oh, there we go. Did I close it? Hold on. Hold on. Are you guys holding on?
Yeah.
Okay, so this is their favor agent. They have, so you know the School of Hard Knocks, right? I pointed you to the Python script that is a few years old now. It has everything. It's like 1,000 lines of code, all the concepts we have, some that we've moved past, just jammed in there. Well, they took that and they said, we're going to make this easy. And they created these two sub-projects in their demo directory to start up Faber and Alice, which are actors in that original script I was pointing to. And so you can literally just come in here. There's instructions on how to do this. Start a new instance. Copy paste their run Faber code snippet, and it will spin up a Faber cloud agent, and you can do another Aries just by clicking another instance. And it's a simple copy paste, connection request, invite type of interaction. So coming here to become familiar with Sovrin is a nice place to learn too. It doesn't teach you the very gritty details of the credentials, but it's a good place to start. So when someone says, where do I go to get started with Sovrin? My response is, well, what's your end goal? What would you like? Are you interested in the Byzantine fault-tolerant algorithm we use for consensus on the ledger? Or are you interested in getting an Aries agent working with Faber? Are you, right? So where does your interest lie? And I think if you're at the agent level of what goes in a wallet, how do I establish connection? I would suggest one here for the Aries.net framework.
So we have a Sovrin test ledger that I can just go on and start throwing stuff into.
Okay, so Lynn is the expert here, and he'll correct me when I get off the tracks. And when someone asks who manages the Sovrin ledger, in my head I made a smart comment. Oh, Lynn does that with help from Michael Bailey, right? And so, but that's a nice comment, right? So we have the main Sovrin ledger, right? That's permission. You have to gain access to a DID with a certain role to be able to write to that ledger. We have a staging net, right? Staging net, which is formerly known as the testing net, which is where you would go to deploy your product before you go to production, right? This is your demo.
Would it be the dev net, not the staging net?
That's what I want. I want the dev net.
So we're getting there.
Yes, we're getting there. So there's 3 in total, right now, and I think a 4th in the works. And so
we're going from most stable to least stable is the
descent
order
I'm
is
going.
in.
Yeah,
So
that's
go
the
ahead.
descent I'm going.
We want to go from most permission, least permission.
Yeah.
Yes.
I want the
Same-
least.
same
I want the
order.
least permission that you have.
So staging net is a more stable, guaranteed uptime, right? And we have
We use the staging app for people who use that for demos, and so we keep that
Right.
mostly
It
running and
needs to
working
be
well.
stable.
Right. So go ahead, Adam. Sorry.
you're free to interrupt the meeting, and also lunch. So the third is dev builder net, which I think of as a dev net, which I think is it. Did we fix what I broke yet? Is it still right? So that's the network you go on to play, right? You go to go test out the new things. That's the ledger we put the transaction author agreement on first, which allowed us to see how it would interrupt interactions, right, with the ledger, how it would affect apps like Aries, Cloud Agent, Python. And so, yeah, there's the builder net. Yes,
And
Nathan.
We talked about setting up a couple of networks beyond that. The builder net's really meant for, I just want to try this, just throwing things on the wall and seeing what sticks.
Right.
We've talked about having a network for people who are actually doing attacks, because often cloud hosting policies don't allow you to do things that are more aggressive. You would like to try out to see how the network is or isn't resilient to certain scenarios. We have not stood that network up yet. We've also talked about having a network that's for the developers to have more direct shell access into the nodes, where we can do more kind of it's fairly easy just to stand up a network on your own laptop and try some things out. So, you can always resort to that. But the hope is that anyone who says, hey, I want to do some credential stuff, they don't have to think about anything watching. They just go get the permissions they need and not think.
Right. The least permission would be just run your own set of nodes on your own laptop.
Yes, but I give my bias though. So going and spinning up a Docker instance with 4 Indy node Plenum servers running on your own machine to connect to and to play with, sometimes there's hiccups. I usually have to update the Genesis transaction file to have the correct IP addresses. Or you have to know what DIDs are in that Genesis transaction file, so you have permissioned DIDs to actually write to the ledger with, right? So coming to an example like the Ares Cloud Agent Python project, they build on top of the Bond verifiable, what's the O? Organization network? What?
BONX.
Yes, BONX. They build on top of their extensions of Node Plenum, which kind of make creating a permission disk easier. They actually make a RESTful API. So this script running is actually doing the hard bits that you'd have to become familiar with.
So setting up a ledger on my old Pentium 5 in the basement
Our ledger
is obviously going to require a certain magical incantation.
So the way they set it up.
So where is the incantation documented that I can execute?
Hey, Lynn, yeah, I could dig up the documentation. There's actually, is it in our Sovrin Rocket Chat or Hyperledger Rocket Chat? A node channel.
There's a getting started document.
Does your Pentium have no run Docker?
No, your Pentium won't run, I'm sorry.
I don't care.
But
I don't need to run Docker. I can put it right on the hardware.
yeah, our hardware requirements are steep.
Do you have 4?
Okay.
So
I've got a Core i5.
I'll get it done.
Memory, so
Well, we need 64 gig, but no, that's a little bit of a joke. I think it's but, okay, so you want to spin up your own ledger. That's the goal, right?
Yeah.
You're going off the rails.
And I need to know the incantation to do it.
Yes, there is documentation. All the tools used are open source. There is a little bit of a gap between, the knowledge of the people managing the networks and the stuff there, but there's a channel on Hyperledger that allows you. Nathan has more.
If anything about standing up nodes or initializing Genesis transaction files sounds intimidating, you probably shouldn't start there. Really, you can just, if you email support at solid.org right now, or the self-service script that Lynn's working on releasing here real soon now, all you have to do is fill out a web form and we'll give you full permissions to whatever you'd like to do on the staging out of the building. And standing up your own nodes isn't necessary until you've kind of got a basic idea on how the credentials work. Because the credentials interaction is really where the exciting, important stuff happens here. Certainly, if you're into consensus algorithms and you really like dealing with the properties of the ledger, that's a good time. I certainly won't discourage you on that. But if you're getting started, getting a feel for how the credentials protocol itself works will help you get started faster than trying to stand up ledger nodes as your first activity.
It is possible. I've seen it done. I
There are
actually
some
had
community members also that have put out a pretty easy to do getting started guide. They run you through the Docker, I think, the Docker stuff, if you're okay with Docker. But they took some of our instructions and they made it into English and layman readable, I should say, because the other is English. But the layman readable format where they walk you through the steps and it's a little bit easier. It doesn't go through everything, but it does give you a good getting started kind of thing to get a node, a set of nodes up and running. So right now you have to have 4 nodes to have a network that is up and running that you can run against.
So I just ran an intern through that setup process using the Docker and getting started. And it was really easy. All the steps are there. Everything from download this and install that to how to launch it. I mean, it's all there. And so that getting started doc is in the GitHub repo folder. And it just kind of walks you through everything. When you're done going through that getting started, you'll have a running Docker answering the local host. Does all of this consensus stuff they're talking about. And so from there, then you can either launch the command line interface, or there's some sample programs that will also connect to local host. And so all of the things you just heard about today, you could just do that. Docker, in my opinion, I don't really like Docker, but I do like the fact that it's a container that just starts everything up, and all these myriad of details I didn't have to deal with. And so from that sense, it just made it really easy.
Yes, Nate.
We try really hard to discourage dependence on Docker production environment. That's really negative qualities for use of us. But everything should be automated, and if you find anything wrong in the readmes or something seems confusing, that's part of why we try to reference the Rocket Chat channels first, is we want you in a position where you can ask a question. Because often when you're involved in the day-to-day development work, you don't see the forest through the trees, and if we can fix something to make those documents better, we want.
So I'm here to help. As soon as you run into any difficulties with that, send me your difficulties and I can walk you through it, get on a Zoom chat with you and show you how to do it. That's what I'm here for. Part of my job is to help other people do what I've done with the main networks that we run and get people up and going. So, and I've done it a couple of times with a couple of different people.
So I actually had a conversation with a gentleman from Hong Kong this last week. And he was saying, I'd like to spin up my own ledger. How does that affect our relationship? We would become competitors. How does, right? And I addressed, well, we don't really, shun, we want to be the main ledger. There's something we're not providing with the Sovrin main ledger. We'd like to correct that. What benefits do you gain, right? So I addressed that, we have people in the community, we're all working on the same code base, and we're all, progressing in this frontier. And I asked, what does it gain you to have your own ledger, right? And he was like, well, I want to make sure only authorized people are writing to the ledger, right? And I explained, well, every node that's hosted on the Sovrin ledger, the individuals have been heavily scrutinized. So it's not just someone in their basement hosting one of the nodes of our ledger. It's a scrutinized organization. And we're tailoring the data structures of what's actually going on the ledger. So it's not a question of who wrote this. It's a question of, can I trust the organization that issued this credential, right? So it comes down to what DIDs or individuals do I trust that issued a credential as a verifier, right? Which goes back into trust frameworks and other things. But so it raises what's on our ledger, right? I'm going to ask a question. What's on our ledger?
Genesis block.
Right? A Genesis block, there's a few different data structures for maintaining, right? So the whole point of our ledger is to be a place for public keys. It's not private information. I'm not putting my private information on the ledger, allowing other people to go and be able to decrypt my information. It's public keys. We don't want anything private on the ledger. And we're working towards being fully compliant with KYC in just like end user agreements type of deals, right? And even in our thinkings, we're strategizing on how we could tombstone blocks and still provide the securities a ledger has. And so the question is, what do you gain from forking the Sovrin ledger or running your own? And it's a lot more maintenance. No, you have to maintain the node.
Or you have to become a sysadmin.
Yeah, you have to become
Nobody wants to be a sysadmin.
right?
right.
And with every node needing to be a supercomputer with like 120 gigabytes of RAM, like, ooh, yeah. No, I'm joking. Our nodes are awesome. But yeah, I don't know. I kind of rambled. But you see the point. There's not a lot to gain from
A cluster of 360
that. Maybe. It comes to the Byzantine fault tolerant algorithm we're using, right? How many nodes can we currently support with Optimize? Or is that proprietary?
I think we're at 25 right now. If you get over 25, then the communication between them gets overwhelming and it slows everything down significantly. So 25 is our current limit.
For active writers.
And that's for an indie node setup of a ledger. Okay, I showed you guys Indie SDK. Oh, the CLI. I talked shortly about the CLI. Lynn, do you want to add anything on the CLI? No, I think we need to be just about done.
I agree. Question.
If you have questions on the CLI, feel free to ask. We can talk about things afterwards. We just want to give an overview. And so I think we're wrapping up on the overview, and lunch is here, ready to go. But any more questions before we head for the whole group before we head over to lunch?
I'll just make a shameless plug and also a comment. If anyone here is interested in more about the use case layer of all this stuff, Riley and I are working on a project called Street Cred, and we just released like kind of I probably shouldn't even mention it because it's so basic right now, but it's essentially an API that allows you to download a digital wallet like Ozma. We have our own version using the agent framework, and then just issue credentials to that wallet and also verify the credentials. So it's at developer.streetcred.id. I'd love feedback on it because it's really basic right now, but it allows you to basically issue and verify credentials without needing to run your own wallet on your local host right now. So
Where's your documentation?
It's in my head still. So developer.streetcred.id. Developer.streetcred.id. And then I'm on Rocket Chat as Michael.Boyd. So this is where you get questions.
I'm going to put all the links I had on this in the US-Utah channel in the Sovrin Rocket Chat. So if you guys join that, you'll be able to find me. Any other questions?
Okay, one more comment before we let you go to get your food. I'm going to go get a paper. I don't know why we don't have one, but I'm going to get a paper for anybody who would like a copy of the recording of this session today, or some of the links that we talked about. We talked about posting all of the links somewhere. I'm not sure where that posting would actually happen, but if you write down your email addresses, we'll send either a link to where that's going to be posted or the actual all the links in that to that email address. And so I'm going to go get that paper right now, and while you're eating lunch, whatever, just come and put your name and email address on that paper, and we'll get this stuff to you. Hey.
Thanks, guys.
Thank you. Have at it.